when you have a portal frame or a steel shed or any kind, or let me say warehouse, or any structure that 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 will be affected with wind and all that. When you are
Mm-hmm.
designing for the base plates or for the base, you are meant to use anchor bolts. You understand? Anchor
Yeah.
bolts. And for that anchor bolt now, we have different types of anchor bolts. We have an L bolt, we have a J bolt, and we have a straight bolt. Now, among these three types of boats, the one that are able to resist wind a lot, or let me say wind effect a lot, is the L boat and the J boat. Now, among these two, it is the J boat that is the best when it comes to the anchor boats on base plate design. So
Okay.
you'll be seeing that as we go on. So once you have come to this place that says base plate, that says base plate connections, right? Then you
Mm-hmm.
have to now click on. Let me send to this. Come in. Hold on. Okay. So when you come to this place now, you have several base plates here. I know that this is for like a hollow section. As you can see the shape there. Then
Mm-hmm.
this is for base plate that is having a stiffener, but I don't normally like to use this because I can still get what I want if I use this one. Then this is just to put a shear key. Know that. So right now I'll click on this simple base plate design. Now you can choose to click on it and then click on the column and you will see this. But I'll just do undo now, or
Mm-hmm.
you hold your shift key first and then click to
Okay.
for you to set it, to like set the properties and what you need. Now you can see that this is the base plate geometry now that you have seen
Yeah.
here. Now we are asked to set our base plate length and the width, right?
Yeah.
And then
Yeah.
to few other parameters. Now, how do we
Mm.
now determine the base plate length and the width? First, we do what we have to do what assume first. Although there are some formulas that you can use to assume your base plate first. Then, if it fails, you can then go and do what increase from there. But before the formula, first, let's go and look at the size of this what pedestal. So we come to this place, back to our software here. You can see that this pedestal is 450. That's what we used last time, 450,
Mm.
right? And it's passing. Now, when you have a pedestal, there is no pedestal that doesn't have a grouting. Now, I think last time I showed you about what to call what to call a grouting, right? I don't know
Yeah.
if you remember. Yes. So, and the grouting is normally 25 millimeter what thickness, and
Mm.
the width from the face of the pedestal is also 25 millimeter. So in that course now, we will have to subtract our pedestal from the size. Sorry, we have to subtract our what? How to subtract our grouting from the size of our what pedestal. Now, knowing that our pedestal is 450, if you minus 25, we are going to have 425, right?
Okay.
425 now becomes our base plates, assume base plate size. But based on principles and based on principle, because normally it is best you work with what principle and not just to be assuming. So based on principle, now this principle will also guide you to know the size of your pedestal when you are
Yeah.
doing your modeling over on the Protastructure or any software. Understand? It will guide you if you know the principle. Now, What is the principle? The base plate size that will sit on a pedestal is column size. The column size that is on the base plate plus 200.
Mhm.
Column
Plus,
size, yeah, the column size that is on the base
mhm.
plate plus 200
Okay.
millimeter plus that is the minimum base plate size you are meant to have.
Okay. Okay. Okay.
Now, if at all your value is giving you an odd number, for example, you're like having 324, it is
Mhm.
best you like do what, round it up with what, 50. For example, now if I calculate this now and this thing is giving me 324, I'll use 350.
Yeah.
Understand?
Yeah.
If it is giving me 410, I will use 450. Understand?
Mhm.
That kind of stuff. But if your value ends with 5, for example, you are having 325, it's okay that way. But if you're having any odd number, for example, 3 4 4 4 to 3, you can say, okay, you can choose to use 425 or
Mhm.
4 to 50 or 450. Understand? But don't allow any odd number. Okay.
Mhm.
So knowing that now, let me allow, Engineer Fashi wants to enter. Come in. Let me allow him to enter. Join now. Uh, yeah, yeah, send link. Close this. Crazy. Oh, I didn't see him again. Okay. So now, knowing that know that that is your formula when it
Okay.
comes to knowing the base plate size is what is the column size of your mute yourself, Anderson, is the column size plus 200. That's the standard. Do you get? Mute yourself,
Yes.
Anderson. Okay, that's fine. So knowing that now, right?
Mhm.
Lower volume, Anderson. Sorry, someone is trying to interfere and enter the sound. Okay, Fashi, yeah. Okay, so knowing that now, and what we have as our pedestal size, this size here is 450. And I've told you
Yeah.
that when you have to subtract your grouting. Do you get?
Okay.
And our grouting is what, 25 minutes. So right now we are using this 425 by 425 based on the size of our pedestal, not based on the principle first. Understand?
Yeah.
I want to
Yeah.
show you how how it will fail, because right now we are not flowing based on the principle. Because if we look at the principle now, going back to our displays here, if we look at this column size here, this column size here
Mhm.
is 300. Can you see that?
Yeah.
It will be 300. Now, if we
Yeah.
add it plus 200, that means that our base plate is meant to be what, 500.
Mhm.
Do you get? Then,
Yeah.
then if our base plate now becomes 500, it is not good for a base plate to like flush directly on the face of the pedestal. There must be
Okay.
a grouting of what, 25 millimeter, where the
Mm.
base plate will like do what, flush. You
Okay.
understand? So what it means is that anything you calculate to get your base plate
Mhm.
size, you have to add 25 millimeter grouting and width. Understand? So
Okay.
that now becomes your size of your pedestal. Do
Mm.
you get?
Yes, sir.
Okay, that's fine. And note, when I mean size, that is the minimum. Based on the design, it might fail. So you have to choose what, go to what, increase. Do you
Mhm.
get? Okay, that's fine. So now this one now we are like using here now is based on the original size of our pedestal, which is what, 450. And then minusing that, will have 425. Okay.
Mm.
Now, once
Yeah.
you've put this and then put this now, the next thing now you now move on to is to put in all these values here. Now,
Mhm.
this particular one here now becomes what, the plate thickness. Now
Mm.
that we have known the size of our what, of our base plates, all right?
That's thickness.
Sorry, is it what?
This is the thickness of the base plate, yeah?
Is it what? Sorry, let me get again. This is
This
base
is
plate.
the thickness. This is the thickness of base plate.
Exactly, yes. So now that we have known the
Yeah,
size, which is the length
yeah,
and the width, it is then
yeah.
for us to know the thickness, right, of
Mm-hmm.
the base plate. Now, thickness too also has its own principle and its own rule. And the rule of base plate thickness is that the base plate thickness must not be um, less than the column flange thickness,
Yeah.
right? So the
Oh,
base plate thickness must not be less than the column flange thickness. Now,
okay.
this principle basically is majorly for an axially loaded what column. And last time I explained to you that we have two type of base plates, either a fixed connection or a pin connection for base plates.
Mhm. Yeah,
And I
yeah.
explained that, yeah, that when you have your either your anchor bolts or your bolts at the four ends of your base plates, that shows
Yes.
that that is a what? That is a fixed
The
end
thick.
what? Yeah, connection. But if you have your bolts around the web of your base
Mm-hmm.
plates, that is a pin. That's a pin moment what? This connection. That means that there is no M value on the base. And last
Yeah.
time I also told you how to remove the moments that once you don't have a hunch. For example, now knowing how this place is here, there's meant to be a hunch connection here. All right. Once this place doesn't have any moment connection, automatically, if you have killed the moment that is here, automatically what is going down to on this column now is only the axial load. And if the axial load is going down to on the column, what is coming to the base is only the axial load. All right.
Yeah.
That means that there is nothing like what there is no
Mhm.
M value, right? Moment on the base. So you
Yeah.
can choose to use a pin connection, having your
It's
bolts around
yeah.
the webs of the
Yeah.
of your column. But if you have a moment connection, for example, a hunch connection, and I will show
Mm-hmm.
you, I will show you I will like show you. Okay, I think, let me just show you now examples of moment connection. Let me just show you on the protasteel. I'll close this after I come back to this one. So right now, if I come to um, beam to column connection, yes. Now you can see that we have several connections here and where and all that. Now
Mm-hmm.
some of them here are for pin connection and some are for moment connection. Now,
Yeah.
the for the very first row here, all the first row you are seeing here are pin connections. All
Mm-hmm.
these first three rows are used
Mm-hmm.
for pin connection. That is for connections that don't have enough moments or that have zero or no moments. And so
Yes.
either less or zero moments, you understand? You
Mm-hmm.
have to use this. They are not they are not that kind of stiff stuffs. Then if you then go down again, the very first one here again, the very first one here is also part of a pin connection. All right. So
Mm-hmm.
1, 2, 3, 4, they are used for pin connection. All right. The first row and one row here is for pin connection.
Exactly.
Then when it comes for moment connection, this one here, that's the second one on this second row. The third one, you can see how the bolts are, and then this fourth one here. So 1, 2, 3, they are for
Mhm.
moment connection. And
Yeah.
once you use any of these connection, 1, 2, 3, on either on your rafter or on your beam to column connection, know that that base will like also be a what? Will also be a moment connection.
Experience. Yeah.
Yes, you understand? Yes. Why these other ones here are for welding. You can see that they are for direct welding, so we don't consider these ones. Then this is for beam to reinforced wall. So those ones,
Mhm.
yeah. But for steel, that's still column to this. Once you have these, sorry, 1, 2, 3, and most times this one too here. So once you
Mm.
have these two, these are moment connections. Why the
Yeah.
first three and here is for pin connection. So once you use any of that on your beam to column connection, automatically your base becomes either pin or fixed based on what you use here. All right. Okay.
Mm.
So now let me go back to that. So knowing that now, go back to base plates. Okay. Then shift enter. Okay. So now let me put back the values here. 425 that we had before and 425. before. So knowing this now, knowing that we have gotten the length of our base plates and the width, the next thing now is the thickness. And I see that thickness of a base plate should not be what? Less than the column flange thickness. That is what axially loaded what? Columns. So
Mm.
yeah, columns. Then if the base plate is to resist moment, it is best to assume 1.75 times the bolt diameter.
Sorry,
One
sir.
point. If now the very first rule, which I said, that
Okay.
that your base plate thickness should not be less than your column flange thickness. And when I mean flange, I mean this. You can see that on the column like this, we
Yes.
have flange and web. This one is the web,
Yeah.
right?
Yeah. Yeah.
So
Yeah.
your your base plate should not be less than your flange thickness. Now,
Yes.
this rule now can most times also work for moment connection. That is,
Mm.
if your base plate thickness is very big, for example, um, let me say you have 20 or something. Yeah, it can also work for a moment connection because that's a very thick plate. But
Mm.
if it is not working, if it is failing, then move to the formula that says 1.75 times the bolt diameter.
Okay.
You understand? Yeah. 1.75 times the bolt diameter.
Diameter.
Okay.
Okay.
Then now that that I've known about the bolt diameter, right? The next
Mm-hmm.
thing now that will come to your mind, how do we then know our bolt size? Right?
Yeah.
But
Yeah.
before we move to that both size, let us put a factor for the put a value for this plate thickness now. So go back to our protastructure now and figure out what is the flange thickness for this column. All right. So I'll come
Mm.
now. I'll open this column now by properties and then check the flange by clicking on this place here. You will be able to see the flange when it opens up. Okay, yeah, you can see the flange. You can see this H1 here. H1, this is
Yeah.
the flange, H1. And we are given what 19 as
Yes.
the at the flange. While 11 is the web. So right now we
Well,
are dealing with what just the 19. So what it means is that from the principle, our base plate now thickness must not be less than 19. So invariably, let's assume 20 first.
okay.
Right? Okay, so we close that now, minimize this, come here and put 20. All right. And then
Yes.
now that we have known that now, if you come here on this other side, they are asking you design standard. Knowing that we have several designs, know that. All right. But what I used to design for the structure was what Eurocode. So
Yeah.
although any code you are using, you just pick the code here. So I'll choose EC3. Then on this place, they are asking us now, what is the minimum plate thickness?
Mm.
Since you have already known how to calculate the plate thickness and you've known your assumed plate thickness is 20 from what we just done now using the flange thickness, right? Know that.
Yes.
So you can choose to put any value here as the minimum, but note that plate thickness varies just as when it comes to reinforced concrete, all right? Reinforcement size varies based on countries, understand? Because what we have here in my country might not be what you have in your country. For example, we don't use size 14 diameter here in my country based on what you understand reinforcement or 15. But in your country, you might have 14 or 15. You understand? Just as yeah. So the same thing happens here. Base plate thickness. Normally, what we have in my country here, we have five. We have five. We have 10 millimeter. We have 12 millimeter. We have 16 millimeter. We have 20. So other countries might have 14, might have 17, 18. You understand? So just as this one says here, minimum. So since you have already known that your assumed is 20, right? You can put
Yeah.
on that, you can put on the maximum for the assumed to be 20, which you already know. And then for this minimum, you can choose to use anything below what you have put here. But make sure you use the actual thickness that at least you can find in your country. So for example, now we in my country we have 10, 12, 16. So I can choose, okay, let me put 12 here. Do you get? So 12
Yes.
becomes my minimum and 20 becomes my maximum. But this 20 was assumed because that is the minimum based on the flange thickness. So
Mm.
if it fails, I can choose to move to 24. All right? I know that. Okay.
Sir, if we, for example, for maximum plate thickness now, if we use 25 or 30,
Okay.
so when
Okay. Yeah.
it fails, automatically it will select that 30 or
Within.
not.
Yeah. Yeah. It's still okay. That's still fine. But when you're picking a plate thickness, always be careful because the more the plate thickness, the more the weight. Understand? Yeah. So don't. Yeah. So although we are going to find the lowest minimum, all right, at least that will not fail and that will not be much SX. So then on this place now that says plate material, yeah, most you can see that we have different grade of steel here, but in my
Mm.
country we use 275. That's what we use as our plates. Or other countries can use 355, but I think the best that is common is 275. So I'll leave it
Okay.
at that. Then when it comes to concrete pedestal, knowing that for a normal reinforced concrete, the minimum the like like the most common or the minimum strength you can or grade of concrete you can use is 25. All right. But when it comes to pedestal, it is most companies, most people, most engineers prefer to use 30. That's because of the kind of force or pressure, like force on that pedestal. You understand? So, and since you're not using so many concrete, it's a steel structure.
Mhm.
They like feel or they choose to use grade 30, which is a strong, like which is strong because that is what is carrying that steel structure. You understand? So most people best to use 30, although you can still use 25, which is the lowest you can use. But for me, I like to use 30, right?
Okay.
Yeah. So once I've added this now, yeah, once I've put all this, now for this place that says and add a stiffener, add stiffener.
Mhm.
I think you know what stiffener is. Like
Yes,
for
yes.
example, yeah. So for me, first you don't just add stiffener like that. You have to
Mhm.
add when there is need for you to add stiffener. For example, if the structure is very high, like more than let me say more than 10 meters high,
Okay.
right? Even if you have the boats, right? Even if the boat is able to hold that that structure, right? Pin it down on the then down on that on that concrete. You are still advised to provide what stiffener plates that will help
Okay.
to like brace between the column and the base plates. You understand? Yeah, so that there won't be any kind of what shifting, all right, movement. Because why? Because what the only connection that is holding the column and the base plate is just welding. All right, that anchor bolt is just the base plate and the pedestal. So since it is only welding that is holding the base plate and the column, and your column is high or you have a very high structure, it is best you add a stiffener plate. But apart from
Okay.
that, there is no need to add a stiffener plate. Understand? Except there is a need for that. Except maybe you have a very high structure or there's a very high moment, all right, on that base. They can choose to add a stiffener plate. Okay, so right now, yeah, our this thing here is 7 meters. But if we try with both and it's still failing, then we can choose to add a stiffener plate. So with this now, I'll leave it. I'll just leave this first. Then I can I will then I then move to anchor boat here, right? On this anchor boat now, they are asking you to choose your what your is still the boat like the boat size, which is the boat name, and what don't forget we are using what 20. Sorry, okay, correct. Now this was are the plates. Now I was saying
Yeah.
about the boat. All right.
Mhm.
Now
Mhm.
for the both sides now, for the both sides, on no account will your both sides be be less than your base plate thickness. So for
Okay.
example now, we are using base plate thickness to be 20.
Chimigos.
Coming to use 12, all right, 12 or 16 as our anchor as our anchor bolt size. That is wrong. You understand? So on no account will your anchor bolt be less than like anchor bolt diameter be less than your base plate thickness. All right. So it is either it's higher or it is equal. You understand? So right now our base plate thickness is 20. All right,
Okay.
it's 20.
Yeah.
So coming to anchor bolt now, if I click
Mhm.
here, we have 16. I cannot use 16 here. They still have
Yes.
auto for like for you to choose. I can't have
Mhm.
16 here, but know that for base plate, minimum size you can use for anchor bolt for any base plate is 16. You
Okay.
understand? But even that 16, when it comes to portal, but just follow the rules. Once you have your base plate thickness, all right, don't
Mhm.
choose any bolt diameter that is below that. All right.
Okay.
Okay. So right now, so since we
But
have 20,
but if we select auto, the software will select it correctly or not?
no, no, no. If you choose auto, most
Mhm.
times you can go and choose 16 for you, which you still come and go and change it. All right.
Okay.
So
Mhm.
instead, I'll pick 20. Now, when I pick
Mhm.
20, if this 20 is not sufficient, it will we are going to see the failure.
Yeah,
You understand?
failure.
It will show. Yeah. Then for this anchor bolt type, all right, you can just leave it that way. Yeah, because even if it's changing, it doesn't really make any meaning because in your country you can have a different type. Understand?
Mhm. Mhm.
Then for this material, note that they have different material.
Yeah.
They have different material. All right. They have grade 4.6, they have grade 4.8, they have different grades. But in my country here, the one that is common is 4.6 or 4. Or 8.8. Understand? Yeah. So and on this place, there is only one option for to but when we go to the boat fully, we will like see other grades, right? So right now I'll just pick this one. Then I'll leave this capacity as it is, 2.6. Then for this whole tolerance, either both tolerance or whole tolerance, it is best to use 2. Now, what does it mean? If there is any error in terms of when they are trying to trying to open or like like to like and drill the hole, all right? This is like a mistake. So if they are meant to drill like 22, yeah, right. So if they are meant to make a mistake, let it not be more than +2. So if they are doing 22 diameter hole, if they are making a mistake, it should not be more than 24. Do you get? So this is like a whole what? You understand? Tolerance. So I will leave that as 2. Then for this welding now, I will leave this one. We will like come back to it when we insert the base plate. I will talk about the welding and the shear key. All right, when to use shear key and when not to use shear key. Okay, so right now, since we have added all our values on this general and for the anchor bolt, the next thing now I'll do, I'll come back here and do what? Set as default. Because if you don't do this, that means that you'll be doing these settings all over and over again for all the base plates.
Okay.
Do you get? So I'll come here, set default, then apply, and then okay. Okay. I'll then click on the base plate on this base plate icon now, zoom in, and let me zoom in now. I'll click here on the stanchion. Right now we now have this now, so I can choose to click on escape. All right, click on the base plate now and then rotate. All right, now on doing this now, you can now see that we have just 2 holes at default, and those 2 holes are found around the web. All right,
Yeah.
which we know that this is the warehouse, and there is a moment that will be on this base. So this will not work. All right. And you can
Mhm.
also see our welding thickness here and all that. Right. But before we proceed, let us generate a report now based on this, right? To see if it is failing or if it is passing. All right. So to like do that now, I'll click on it and then just rotate it, and then I can choose to highlight. I'll just highlight like this. All right. Highlight it by clicking here, holding this place, and then sorry, just click once and then hold it. Then move your hand backward to highlight. Now, on doing this now, you then come to drawings and what? Reports. Come to create. This one is to create reports. Come to create and then choose the code which you're using. In this case, I'm using what? EC3. So I'll click on it. Wait for it to open. Okay. Wait for it to open. It will open yeah, correct. So this is now the report now. Now you can see the base on that. If I scroll down now, scroll down. Now, this is where your checking starts, right?
Okay.
Geometry checks. First, let me zoom in. Okay. So first, now this is the bolt gauge, all right? Bolt
Mm.
gauge, we on our base plate now, we have X direction and Y direction. Hope you know that, right? We have on the length and on the width, right?
Yeah.
So in that case, there will al- there will be check also on the base plates, sorry, on the bolts based on the X arrangement and the Y arrangement. Do you get?
Yeah.
So right now, this is the first check, right? You can see that this is the first check, and this yes here simply means that it is okay, all right?
Okay.
Means that this boat on this direction is okay. Then if we move down again, we then have what? Plate width. Plate width. All right.
Mm.
You can see that the plate width here, this is failing. Once you see this place, right? Once you see this informative, it means that it like in fact it's just and call it failing. All right. But just know that it is about to pass, but it's not yet okay. Understand? It's like a
Okay.
near miss. So you seem to check it. So right now I would like call it a failure. All right. But most times you like see it, they just write it fail, fail. But right
Yeah.
now this is a near miss. So even if it's a near miss, as long as it is not showing yes, it means that it has an issue. So it is failing. All right. We then go again for both gauge again, both gauge on the other direction. Here now you can see that here is failing, right? Then we then go now for the welding check, for the
Mm.
weld check, welding. Yes, for the weld check, it is passing, but there is a principle or rule when it comes to welding. Okay. Now,
Mhm.
based on these failures we have seen now, and for this weld now, we then talk about what? Bolts and the weld. Okay, so I'll close the report now and then go and then click on those things. So I'll close it now. Okay, then close this. Now, let us focus first on the welding. Yes, for the welding is in passing, but it is best to know the principle of the weld size. All right. Now,
Mhm.
these things you're seeing here are the welds. All these yellow things you're seeing here are the weld. And don't forget, remember, I told you that the only thing that is connecting the column and the base plate is the weld. So
Yeah.
if the weld is not sufficient, what it means is that this column will like do what? Will like shift, will like break off from the base plate,
Yeah. Yeah.
right? That is why most times, if the structure is a very high structure, more than 10 meters high, right? What they do, even if they provide a sufficient weld, they'll still provide what? A stiffener plate that will weld on this column and weld on the base plate. So you understand? So with that now, they are providing additional support, all right? So that there will not be any form of what? Rotation on the base between the column and the base plate. Do you get? So with that now, let us now look at the weld size. So for the weld size now, for or the principle for weld size, knowing that we'll have several type of weld, we'll have different kind of weld, but I will deal on the most common type of weld, which is what? Fillet weld. All right, fillet weld. So, for example, this is also a fillet weld. As you can see that, that's what we use most of the times for structural for our structures, except most if you're dealing with if you're dealing with a hollow sections, that's where you can be dealing with a complete weld and all that. Okay, so right now for a fillet weld based on weld size, the weld size shall be should be equal to or greater than the smallest plate thickness that is going to weld together. So the principle of that is of a weld size is that the the weld size or the weld thickness should be equal to or greater than the smallest plate thickness that is coming to weld together.
Okay.
Now, if this my hand now is the base plate,
Yeah.
and this other hand here is the column.
Yeah.
This plate, this base plate has a thickness. This column, if it's a H beam or an I section, it has two thicknesses,
Yeah.
yeah, which is the flange and the web,
Oh, yeah.
right? And the web. So in that course now, in that course, I'll have to look out for or find out the smallest thickness between the base plate and the column. So in this now, or for this now, we already know that this base plate was 20 millimeter thickness, right?
Yeah.
Then for us to now figure out the like the both thicknesses that we'll have here on this stanchion, I'll come back to this place here. Although I think I can still look at it. Let me see if I see double click on this stanchion here, it can open the property for me. Let me see. Yeah, correct. So you can see here, we have the length and the width 300, but the web now is 11 and the flange is what 19. So right now, this base plate is 20. For this column, the flange is 19,
Yeah.
and for the web for the column is 11. So automatically right now, 11 becomes the smallest or the
So,
yeah, this like the it becomes the smallest for thickness. And
mhm.
from the rule of our welding thickness, it says that the welding thickness should be equal to or greater than than the smallest plate thickness, all right? And it's coming to join together. Do you get?
Okay.
That's fine. But if you still go further in standard, for standard, now this is a principle, all right, that governs a lot. But most times there's also another standard that has a formula that can use to calculate your welding thickness. And that formula is 0.75 times the base plate thickness. All right?
Yeah. Yes, sir.
That 0.75 times the plate thickness. So now, note that this principle I am giving you now is not only for base plates. When we move to other type of this into connection, it is the same principle. You understand? Yeah. So 0.75 times the plate thickness. All right.
Yeah.
Okay. So right now, if our plate thickness, now that our this is 20 multiplied by 0.75, you can see that this is 15. So right now we now have two principles we are working with, or that can work. One says that weld thickness should be equal to or greater than the smallest thickness that's going to weld together, right?
Yes.
Then we also have that 0.75 times the plate thickness,
Mhm.
right? So right now, what it means is that we can play with 11, we can play with from 11 to 15, right?
Okay.
So I can choose to use 12 as my plate thickness
Mhm.
because 12 now is like an average or at the middle between the lowest and the other formula. So with that now, 12 becomes my welding thickness. So I'll come now, I'll double click on this. Now, note, when your weld, don't go and increase your weld thickness too much, because if the weld thickness is too much, it will melt it will melt the smallest thickness of the uh, either the column or the base plates.
Yeah, yeah.
Understand? So note, don't go and choose much size. So with
Mm-hmm.
that, so knowing that now, I'll come and change all my weld thickness down to to 12. All right. There
Okay.
is no principle that there is no way yet to like do all together. So I'll just double click on it now and then come here and change it to 12. All right. And
Okay.
then note also that you can see that there is a they have here welding operation. There are two ways of welding, either workshop or site. Now this one here will be welded at what at the workshop. That's because they will like carry it with this column welded together with the base plates and the openings and the bolt openings, and then come to the site and then mount it and then bolt it. Do you get? So
Mm-hmm.
this is a workshop weld. So I'll leave here as it is workshop. Else I would have chosen site, but I'll come here and choose workshop. All right.
Okay.
Then I'll leave every other things here as this. They don't really they don't really mean. Once you put in your weld thickness, and then normally a fillet weld is normally at what angle 45. So angle 45, and then come here and choose this. Every other one here, finishing or contours, you can leave those ones.
Okay.
Then I'll come now. I'll say set as default, then say apply and okay. Now I can see that this word now has now increased in size based on the other ones. All right.
Okay.
Now let me see if there's any way to make it to like change all at once. Let me just pick like two and then right click. Don't know if that's whatever. View properties. Let me see. Okay, I think let me see. Is it no way? No way. So normally I normally do it, but had it been I
Yeah.
set it before when I was doing here, it would have taken as 12. But why? I wanted to leave it just to explain to you what, because that would have taken time. So right now, just change it. So if you're doing it by yourself, when you come here, while you're setting all these ones here, when you come to
Mm-hmm.
weld, right, calculate your weld thickness and then put the weld size, all right, so that I'm not, you understand what I mean? Put the word size so that when you say set as default, it will it will pick it. Do you get?
Yeah.
Correct. So here now, this one means that this one that has a flag at the top means that it's a workshop weld. Come again, workshop weld. All right. I'll come here, angle 45. Then this share key, I start explaining to you. So I won't put anything here. I'll just leave it at the seat. So once you put this, and then put this here, you can leave everything as default. Then I would have said, okay, let me just say apply. I think everything here is okay. Yes. Apply default, apply, and okay. Okay, that's fine. So, but let me just change these ones that I've already done already to 12, and then just apply okay. Come again here. 12, apply okay. Apply okay. Rotate and come here, double click here, change here to 12, apply okay, apply okay,
Mm-hmm.
come again on here, double click here, 12, apply okay, okay, then turn like this, click here, 12, apply okay, click here, 12, apply okay, okay, then rotate again. Let me see here, double click here, 12, apply okay, double click here, 12, apply okay. This one here, sorry, another one. this. Sorry. Let me see. Yeah. 12 apply. Okay. Okay. I think one here. This one. This last one. I think so. 12 apply. Okay. Let me see here. Yeah, that's right. Okay, so that is the rule for weld, right? So right now we have done rule for weld, for both for base plate thickness, base plate size, and then what that rule again? Yeah, base plate size, and for both size. Now let's now move to um, edge distance and bolt to bolt distance. But right now we are now moving to bolts, knowing that these bolts we are failing. It was a failure, right? Based on the bolt gauge.
Zero, it's not showing the bolt.
No, hold on. Yeah, don't hold on. You like we like get to like that. Now, note the reason why it's not why we are not going to show the boat, like we will like show the boats, but first we have to treat it first based on the openings first, because that is what they will do at the workshop. It's just the opening. Why the boats? They are going to cast it with this concrete pedestal. Do you get?
Yes.
So let us deal with the opening first. Then once we get all the openings right,
Mm-hmm.
even without the bolts, once your opening is right, then when you get your report, you see that it will pass, because if it is from your bolt size that you get your opening size. Do you get?
Okay.
Exactly. So right now, to first now do the bolt now, also do the bolt now. We on the bolt, we are going to talk about edge distance, bolt to bolt distance, these
Mm-hmm.
two. So right now, for us to now have or add other bolts
Yes.
or opening, knowing that we want this opening to be on the fore edge, knowing that this will be a moment what connection. So
Mm-hmm.
we want this bolt now to be on the four edges. All right.
Yeah.
Now I will click on this opening now. Just double click on it. Double click on the opening to open the bolt property.
Mm-hmm.
Now, when you come to this place now, you can see that you have two choice: bolt or
Holes.
hole.
Yeah.
Hole. Can you see that?
Yeah.
Now, if you choose this bolt,
Mm-hmm.
what you're saying is that, because this is not an anchor bolt, this bolt here is like if I was bolting this tension to another steel beam,
Yeah.
I'll be using a normal boat, very
Normal.
short boat,
Yes.
and not an anchor boat. Understand? But this boat we are going to add on this base plate is going to the pedestal, which is a
Yeah.
concrete.
Yeah. Yeah.
So that will be a very long boat, which is an anchor
Mm.
boat.
Anchor bolt.
Understand? So yeah. So with that now, when I double click on this opening, I will not come and pick boat. Else it will give me that short boat, just like as you're seeing this short boat here, right? Which is not nice. So I'll click on opening. All right. I'll use the opening. Now for opening now, they're asking you what is your opening diameter or your hole diameter. All right,
Okay.
your whole diameter. Now for the whole diameter now, for the whole diameter, we get our whole diameter by adding +2 on the both sides. So for example, if you're using a 12 diameter bolt, you will say M12,
Mm-hmm.
right? M12 millimeter or M12 diameter bolts for for 14 hole. You
Yeah.
understand? You understand? Yeah. So right now our bolt is what is 20,
Oh,
right?
should be, yeah.
20 diameter. That means that our hole will be minimum 22 diameter opening,
Yeah.
or at maximum 24, because of what? Of the we have a hole tolerance of what? 2. Do you get?
Oh, yeah.
Yeah. So minimum is 22 because of adding +2, and maximum is 24 because of what? Or the bolt tolerance. Yeah.
Mm.
Okay, so right now we'll leave it as for 22 as it is here. Since we are not using bolts here, I will not add any bolt assembly here.
Mm-hmm.
Else, I don't mean like click here, you would have put your bolt assembly, which in this case would have put either 4.6 underscore class or 8.8 underscore class. That's just the grade, right? The grade of bolts. So
Okay.
right now, I'll just come back here and put here. So I didn't know I was here, I would have put either 8.8 underscore, sorry, underscore class. That means that I'm saying that I'm using 8.8 grid class of both. But in this
Mm-hmm.
case, we are using whole. So I'll come back to whole right now. Yeah. So then the next thing now, I am on setting one. Setting two now, I don't really need that because I'm not using both, right? But
Mm-hmm.
yeah, I'm not using both. Then setting three too, I'll skip it too. I'll then move to position. Position now, right?
Yeah.
So once I'm done with setting one, putting my whole diameter and then choosing hole instead of both,
Mm-hmm.
and then move to position. No need to check washer because we are not using any of this, right? When we come to the anchor bolt, you will like see that that one has its own different this thing, right? Different dialog box. So I'll then come to position here. Now on this position now, since that we have just two bolts, one here
Mm-hmm.
and one on the other face. That's why you
Yeah.
are seeing it has only two here. Can you see that? But we
Mm-hmm.
want to achieve four first and then check our design. If it is okay, we then leave it as it is. Else, we are going to add more bolts, right?
Mm-hmm.
So right now, let's now begin to do that. Now, how do we now know the exact position or the value to type for these bolts for this hole to be found at the edges? Now, when I mean edges, don't forget there will be an edge distance calculation between
Mm-hmm.
the bolt diameter and the base plate edge. So right now, to do this now, we have to open our what calculator now. Calculator. Now, sorry, come like this. Now, what is our base plate size? 425, right?
Yes.
Now, 425 to get your 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 bolt at the edges, right? You do 425 divided by 2. That is the base plate, not 425, the base plate dimension divided by 2. All right?
Mm-hmm.
You will have a value. Now, minus your edge distance. Now, let's now calculate our edge distance separately first. So I'll cancel
Okay.
this. Now, edge distance now. What is the edge? What's an edge distance? An edge distance, or both to, yeah, an edge distance is the distance between the center of the bolt to the
Mm-hmm.
edge of the base plate or to the edge of any plate. Don't forget, I said that this rule I'm using now is for not only for base plate, for all that kind of connections. You understand that will involve plate and bolt, right? So
Yeah.
an edge distance now is the the distance between the center of the hole or of the bolt to the base plate or the plates, right?
Okay.
Yeah. So right now, and most times it is not less than 2 times the base plate, but the formula is actually 1.5 times the bolt diameter. Can you hear me?
Yes, sir.
1.5 times the bolt diameter. That is the formula.
Okay.
Then, yeah, but now note that this formula is the minimum. That is the minimum, not the maximum. Is the minimum. All right. So you can choose to go further by adding a value, either 2, 5, 10, or something to that minimum value that you got. Now, note that most times when the base plate or yeah is having a very high a very high moment, or is going to resist a very high moment, the formula most times changes to 2.5 times the bolt diameter. That is only for base plate now. The other 1.5 times the bolt diameter is for general connections. Even if for pole lines, for anything, you use that one. That one also works for base plates. But now, if the base plate is having going to resist a very high moment, all right, we then
Okay.
move to using 2.5
Mhm.
times the bolt diameter. All right,
Okay.
that's fine. But before you use that, you must test the 1.5 times. Then, if it is failing, you then begin to add, right, or use the 2.5 times bolt diameter, right? Then that is for edge distance. Now, we also have a rule for bolt to bolt distance. For example, if I have a bolt here and I have another bolt again, okay, yeah, another bolt again, there is a rule for bolt to bolt distance, all right? And
Okay.
that is 2.5 times the bolt diameter. This
Mhm.
one works for every other connections, either base plates or anyone at all. 2.5 times the bolt diameter. Note, these formulas are the minimum. You can choose to add. Now, when you're adding, don't add too much. You can add 2. So, for example, if you get 30 as your, let me say, when you times it and all that, get 30, you can choose to use 32. Don't always use the minimum, except when you are, when you don't have space again, you can choose to use the minimum at the dots. But else, add like 2 or 5. So instead of using like 30, I can say 32 or 35 or 40 or 45.
Okay.
Most times 50. But going more than by adding plus 20, let me say you're
Mhm.
adding plus 30, that will take the boat far away from the edge. Understand? Before you know now, you'll be having a pin connection and no more a moment connection. You understand? So don't add too much value that will take the boat away from the edge. So most times you add maximum plus 20. That's the maximum you can add. You understand what I mean? So if you have 30 and then you have tried 32, 35, 40, 42, 45, you can then have 50 as a maximum.
Okay.
If it's still failing, then add more bolts. You understand? To the base plate. Okay. So now that we have known the formula, 1.5 times the bolt diameter, let's now calculate first the edge distance. So our bolt is what? 20, right? Diameter. So we have to come now and do what? And do 1.5 times 20. This
Okay.
gives us 30 as a minimum, as minimum edge distance. Do you get? So
Yes.
with so so with this now, I say you can choose to add something on it. For me, I like to add 5, all right? Most times 10. But
Mhm.
let us start with 5 first. So with that now, that means that my boat distance becomes what? 35, right? My edge distance,
Okay.
right? Correct. So now that we have known our edge distance now, let's now move this boat to this place. And how do I say move it? You move it by doing what? By, sorry, let me just do this. By the plate thickness. Sorry, the plate dimension,
Mhm.
right? Divided by 2 minus the edge distance, which we have
Mhm.
now to be 35.
33.
Now I'm having 178. I'll just do what? I'll just take one. Sorry, 177.5. I'll just take 178, right?
Mhm.
Now 178 now becomes the the value that will take this boat to this edge, all right? To these
Yeah.
edges. So I'll come now. I'll minimize the tabulator, then come here, all right? I hope you still know how we got here to this place. This is for the position. We are
Mhm.
here before. Then click on the position, you now get this. So correct. So now we now have 178 as our boat location. All right. So I'll
Mhm.
come now and put in 178. All right. And then you can see that y is 0. 0 means that
That's
now
in the center.
178, yeah, center. So and I want it to be on the edge. So I'll come again here and put 178. So what it means is that it has pushed this boat like this and then like this. So it will be found here. I'll come here and say what? Update. Come again here. This is the one that has here. I'll come and change this also to 178, 178, and 178. All right. I'll say what? Update. Now, we want to have 4 boats. All right. Now,
Yeah.
178 is the only value that we are going to be using, but we have to control the positions now by adding minus, plus, and all that, right? So right
Mm-hmm.
now, the first one here will have plus, plus, right?
Yes, sir.
Here we'll have minus,
It's
plus.
coordinates, yeah? It's by coordinate.
Yes, yes. But right now, we have plus, plus. Can you see that on this value?
Mm,
Then here we have minus, plus, right?
mm, mm-hmm.
I will come now and say add because I want to add up to 4 boats. Here now, I will say my plus minus, right? Plus minus.
Sorry, sir,
I'll
from where it's getting the reference?
you say what?
From where it's getting its reference? 00, where is it is?
No, no. Right now, we are getting this value based on just this base plate, not from the whole structure. On
Okay.
this base plate, from the center
It's
of the base plate
local.
now.
It's local of this
Base
plate.
plate, yes,
Yeah, yeah.
yes, from the center, yeah. So right now we have plus plus minus plus, and I'll have plus minus. Okay, I'll now come and say again, add again. All right, I'll now
From,
have minus minus.
okay.
Yeah, correct. So with this now, I'll then say now update. So with this, let me see now. Oh no, I think this one is meant to be meant to be plus minus. Yes. So make sure no one is having the same thing to update. So right now I have plus plus, minus plus, plus minus, and then minus minus. So once you have done this, then now come and do what? Click on here that says you can say default, default,
Mm,
and then apply, and then okay. Can you
mhm.
see this now?
Yes, sir.
We then have this now on the 4 edges. So the edge distance now is the center of this boat to the edge of this base plate, and also here too, the center of this boat to the other direction to this other base plate here. Okay, that's fine. So with this now, before we begin to add the boat, let us see our let us see our what go and create a report to see first if um if these 4 boats or what we have currently is okay. All right, so I'll come again now, go like this. All right, highlight,
Mm,
highlight like this,
okay.
come to this place, create report. Let's see now again, it will see create in the report again. I'll then go now. You can see that we now have 4 boats now. Then I'll see it again. Now we still have a failure here, which is on the boat gauge. One of the face is passing. One of the face needs more boats. That 2 boat is not enough to carry that.
Mm,
Again, now I can see that other ones now have passed. Before we are having failure based on edge distance, both edge distance. But now that we have put the right value, now I can see that it's given minimum to be 33, right? But what we are providing was 45 or something. So sorry, and 35. So with that, years passed, passed. Right? Yes. Then you can see our edge, sorry, weld now. Our weld now becomes 12 millimeter, which we have done before, right? Which you did, right? Which is also okay. Now, the only thing that is failing now is this here, which is still under the boat gauge, right?
mhm.
The boat is failing. So what it means now is that on one of the face, the boat is okay, but on the other face, the boat is not okay. That
Not
means we need to
sufficient.
add more boats to that. Okay, so let us close this other report again right now, and then close this again. Then we'll take this. Now, as you can see now, we have this phase here, and then this other phase here. All right? Can you see me?
Yeah. Sir,
We have this phase.
sorry,
Okay, let
sir.
me hear. Let me hear.
Now we have just holes, nah? Even we
Hold on.
have,
Hold on. Yeah. I said for you before that if the hole fails, the boat fails because what controls your hole size is the boat
okay,
diameter. So if you choose the right boat, all right, that means that if if the base plate passes with the hole.
Okay.
When we are going to add bolts, anchor bolt to it, it will still
Okay.
pass, right? Which I'll show
Okay.
you again how to add anchor bolts to like this.
Yeah, yeah, got
Okay,
it.
exactly. So right now we are going to add bolts. Now you will be asking yourself, where are we going to add it? Because right now it is failing on just one side, and we don't know the right side yet that is failing, because we
Mm,
have this face facing the web, and this face facing the flange, right? So you
mm,
can choose to add it here first. If you check your report, it's still failing, then know that it is not this direction, it is on this direction. So I'll come again now, double click again on this bolt here, then come to position here. All right. Now we need to add additional more two. Let's say two, let's say either one here and one on that face. Yes, and then
mm.
test first. If it's not failing on that face, we then take it off and then add it one here and one on that face.
Yeah, got
So
it.
with that now, to put this value, to put a bolt now on this center,
Mm,
or on this center, one
yes.
of our value will be 0, because that is on the 0 line, right?
Mm-hmm.
0 line, all right? 0 line. So with that now, let's see this. So I'll click on this now, and then say, just here, and then say add. I'll come now, make one of these. Sorry, make one of these 0, 0, and then update. Let's click on apply. Let's see where it is. Let me see. I need to see where it is. Let me just say okay first, and
Okay.
let's see where it is showing. Okay, you can see it here, right?
Yeah, yeah.
Yeah, correct. So that right now, let us do again, and then take off the minus, so I can come here.
Yes,
I'll go
yes.
again and add again. Compose position. This is that one here. Add and take off the minus from that one. Um, then click on update,
Uh,
apply.
okay.
Correct. Now click on, let me just say set default, and then say apply OK. So right, let's now check the report again to see if
Where you are clicking set default?
now what I mean by set default is that when I'm going to design for other base plate, I won't be doing this whole setting again.
Sorry?
The reason why I'm saying set as default, so that
Okay.
when I'm designing for these other base plates, I won't
Okay.
be doing this whole setting again afresh. It will just pick it. Do you get?
Okay.
Yeah. So that's why I'm saying set default. Okay. So let us go back again now. So I'll come now, highlight this again like this. Right. Sorry. Come here and click on the report again. I like to open. Go back again. Now you can see that it is still. That means that it is not the right. It is not the right direction. So let's
Yeah.
go and change it. So I'll close it again now. Close this place again. Come back here. Open this place again. The boat.
Mm.
Now what will I do? I'll just change it 0
Then
first, and then
yeah.
the other one last. So I'll come here. Just copy this or cut it. 0 here now. Click here and then paste that value. Say
Mhm.
update. Come 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 again here. Cut this. 0. Sorry, 0 becomes first. Then come here, paste this, and then update. And
Set
let me,
default.
yeah, set current, apply, and this. Okay, that's fine. So you
So
can
by
now see this now. Okay,
set as
let me,
default, we can apply it for other pedestals also.
exactly. Once you're choosing that set as default,
Mm.
when we are going to place another one now, we are not going to do these settings again. So once we get the right one that is okay, you just be putting that same one. But although you need to check the report to see if that setting, if this setting is okay for the next column, because the load this column might be carrying might be different from what this one is carrying. Do you get? You must check the like the report of each of them. Okay, so right now let's now do the report now for this again. So I'll come like this now, highlight
Mhm.
this again. come here and EC3 for the report. Okay. Then go again. Okay, so you can now see that it's not passing, right? Let me minimize. Can you see it now? We have our first bolt gauge passed, and here
Yeah.
to pass, and here pass, 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 pass. So you must not see any of that showing either failure or something. You must see it pass or yes. Either this pass here or yes, yes, yes. All right. So you can see that. So with this now, we have designed for the base plate and the bolts. Let's now go and add anchor bolts. All right. So right now we have known that this base plate now is okay. All right, based on the report and everything that you're seeing here. So you can choose to save it as PDF or something by normally export to PDF if you have that export to PDF here or something. So I'll close this, okay, and close it again. Then save first. Okay. So now to now add an anchor bolt, I'll just rotate this again. Rotate this now. Now to add anchor bolt, for me, first thing I need to do is to hide this pedestal, because I want to see how the anchor bolt will like appear inside the pedestal before I now add it back. All right? Can you hear me? Hello?
Yes, yes, yes,
Okay,
sir.
that's fine. So I will hide this now. I will hide this pedestal. I'll come here, right click here and say hide selected.
Mm-hmm.
All right. So I now, before I go to that pedestal, sorry, the anchor bolt, I said that I would like to talk about the share key. You can see a share key here, right? All right. Now,
Okay.
most times, most people